This video was made possible by Skillshare. Learn what you want to learn with Skillshare for free for 2 months at the link in the description. Imagine a patented apple. Just like only Nabisco can sell Oreos and only Unilever can sell Marmite, imagine there was only one company worldwide with the right to harvest apples. That would be ridiculous, wouldn't it? Now imagine a patented gene sequence. Imagine a single company had exclusive rights to all usages of a particular section of the human genome. That would also be absurd, right? Back in 1990, renowned geneticist Mary Claire King made an announcement that shook the world. She and her research team had discovered that somewhere in this section of the 17th chromosome was a gene linked to breast cancer. She didn't know exactly where it was, or what it was, or why it was linked to cancer. All she knew was that it was there. What followed was a race to find this so-called breast cancer gene. Colleges, companies, and governments all devoted enormous resources to finding the gene that could tell people, with relative accuracy, whether they would contract cancer years before any other test. With preventative mastectomies, survival rates for this type of cancer could skyrocket. Then, in 1994, it happened. A team of researchers from the University of Utah announced that they had found the gene, BRCA1. Soon after, they found another similar gene with nearly identical effects, BRCA2. Females found to have a mutation in one of these two genes had an 80% chance of contracting breast cancer in their lifetimes. But the good news was that you could test for it. This was a life-changing breakthrough for the thousands found to have the mutation yearly. Some of the researchers from the University of Utah saw the commercial application of this and founded a company, Myriad Genetics, which soon patented the two genes, quite literally. In their patent document is the full genetic sequence of the BRCA1 gene, 21,328 characters of G's, C's, A's, and T's that represent what is in the human body. They patented something inside you, something not all that different than patenting that apple. The apple is too just a long sequence of G's, C's, A's, and T's. The only difference is that it's longer. Myriad Genetics, as the only company globally allowed to do anything with the BRCA genes, had an absolute monopoly on testing. If you wanted to see if you had the gene mutation that would give you a heads up on cancer, you had to go to Myriad. And so it came at a price. Up to $4,000, even though the actual process of performing the test cost only a fraction of that. This was almost certainly unjust, and so the ACLU took notice. They, along with a group of plaintiffs, sued Myriad Genetics on the basis that their patents were on non-patentable material, the human genome. Much like you can't patent an apple because you didn't create the apple, the plaintiffs argued that Myriad couldn't patent the genes because they didn't create them. Nature did. But Myriad was not alone in the process of patenting genes. In fact, at the time, 21% of the human genome had been patented. The district court ended up ruling in the plaintiff's favor, so Myriad appealed and the case went to a federal appeals court that ended up ruling in Myriad's favor, so the ACLU petitioned for their case to be heard in the Supreme Court. They agreed, and on April 15th, the case for the Association of Molecular Pathology versus Myriad Genetics Incorporated reached Washington. In a stunning turn of events, all 9 Supreme Court justices sided in the plaintiff's favor, therefore virtually ending the process of human genome patents. But was it right? Up to this point, Myriad has probably seemed like the bad guy. But consider this. The individuals who founded Myriad were the ones that discovered the effect of the gene mutation in question, so shouldn't they be rewarded for their years of work? That's really the question with all patents. On one hand, patents drive innovation because they allow companies to monetize discoveries that cost huge amounts to research and develop, but on the other hand, restrictive patents and monopolies stop these innovations from getting to the people who need them most. Without the ability to make money off of genetic testing, it can be argued that many companies won't have the motivation to research genetic predispositions. So that brings us to the critical question, what should be patentable? There are certainly cases where patents on genetic material have helped. In this age where editing genome sequences is cheap and easy, it's very possible for companies to modify organisms in a way that make them true original creations that can be legitimately patented. For example, the apple we talked about at the beginning could not be patented, but a genetically modified apple? That's fair game. In fact, Patents on genetically modified food have existed for decades. Golden rice is a much lauded yet controversial variety of genetically modified rice that includes a high amount of beta-carotene, which helps treat vitamin A deficiency, an affliction that kills up to 2 million individuals yearly in developing countries. As a crop that is cheap, easy to cultivate, and